Okay, nice to see you still here. Right, what I thought I'd just start with, because I found as I've been marking some of this 91161 work, it's really useful, as I tried to explain last time, to use units to help you work out in your working so you land up with the correct answer. So these are the standard units, and here's a sort of like a little poem. So you've got to know that volume is liter, amount is mole, mass is gram. So if you get given a mass in kilogram, you have to convert to gram. Or if you get given a volume in milliliters, you have to convert to liters. Okay, because the way these will cancel out is, if I try and sort of just show here, if I get given a mass in kilogram, so using my n is equal to small m over big M, so just have that picture to remind you. So can you see my unit of n is mole, and can you see if I get given a mass in kilogram and I use the molar mass of gram per mole, will the kilogram and the gram cancel out? Are they the same units, kilogram and gram? So if I change this, can I cancel this kilogram with the gram and get an answer of mole? No, I can't, because a kilogram is 1,000 times bigger than a gram. So they won't cancel out. So I can't do this. Okay? So my unit, if I don't convert my mass of kilograms to grams, is going to be this very weird kilogram per gram mole. Because remember that mole to the -1 at the bottom becomes mole at the top. So that's a very weird unit. So if you land up with a weird unit, you know you've made a mistake. Okay, so as I say, this poem is volume, amount, and mass of units without a dash, liter, mole, and gram, and you learn these as soon as you can. But molar mass and concentration have ideas above the station, double-barreled, not repeated, so double-barreled, I've got two things on there, so gram per mole and mole per liter. So there's two things in that compared to just one over there. So I don't know if that's going to help you remember. Okay, so let's carry on with the one-step calculations very quickly. Now the one-step is for achieved level, two-step is for merit level, and three-step, where you use the molar mass, is for three-step, is for excellence, sorry. So remember what I said, when you get given a question, just underline what you the keywords. So mass is obviously a keyword. We've got to calculate, and you could even write the symbol above it, the small m. I am given that. What is 0.125 mole in terms of my little, oh, sorry, I meant to, in terms of my formula of n is equal to small m over big M? What does it, which one of these does it represent? The m, the small m, or the big M? The n. So you could write n over there, highlight it, okay? And then you get given a whole lot of this stuff, and hopefully you know that is your big M that you have to calculate. So always start with your molar mass, because you've got to do that step somewhere, so you might as well do it now. So remember, how many sodiums have I got? I've got 2, okay, so a non, well done. Emma, can you see there I've got the Na and a small 2 after it. The small number applies to the element immediately in front. So that 2 applies to the sodium. So I've got 2 sodiums, so it's 2 times 23. Okay, 0.0, because you should actually keep that all. But I'm just going to say here M. Now it's also a good idea to say what that substance is, particularly with a two-step. Yep, and Emma, It is so easy to make a mistake, a careless transcription error, a careless misreading of the question. It's so easy. So, carbons. How many carbons have I got? 1. Great, Shannon. Hi, Shannon there. Okay, so I've got one of those, so it's just 12, and as I say, you should actually really put in your decimal places because you've got to look at your significant figures. And how many oxygens have I got? 3. Great. So it's 3 times 16. And, I find these pens not easy to work with. I don't know if you find your pens easy. And, oh, I have not got my calculator up here. Somebody must have borrowed it. Okay, so I'll just use my computer calculator, or can you also work that out very quickly? So I've got 46 plus 12 plus 48, because 3 times 16 is 48. Do you get 106? Yep. Okay, so remember that's 106 grams per mole. Now I know I'm really harping on about units, but it does help you stop making silly errors if you write your units in there. Okay, so you've got now N, you've got big M, so you've just got to work out the mass. Now if N is equal to small m over big M, to change the subject of the formula, I just want small m by itself. So do I multiply the N by the big M, or do I divide it? How can I get small m by itself? So if I just change my color, I want to get rid of this big M, so what do I do with it? You multiply, because you multiply both sides of the equation. So if I multiply this by M, you can see that'll cancel, so I've got to multiply that side by M. So that's going to be equal to N times big M, so it's going to be 125. Now 0.125. How many significant figures is 0.125? 3. So your answer should be to 3 significant figures. Well, it's supposed to be to the least accurate one. And 0.125 is to 3 significant figures. 106, and I should have been putting that 0 in because there should have been a 0 there as well. Okay, and that should have been a 16.02. So I've got 4 significant figures here. I've got 3 significant figures there, so my answer should be to the least accurate data, so your answer should be to 3 significant figures. Keep at least 3 significant figures during your working. For excellence, if you drop down to 2 significant figures in your working and then give an answer to 3 significant figures, it's still wrong. Okay, so make sure you have at least 3 significant figures during your working. And does anybody have a calculator handy to work out what that answer is? Shannon is typing. Okay, I get 13.25. Okay, now what is your unit first of all? Grams. Okay, and it is grams because we've had grams per mole and we've had moles, so the moles cancel out, leaving me with grams. Now, is my answer to 3 significant figures? No, so this won't get excellence, it'll only get merit. Well, it's only a 1 step, so it's only really an achieve level question, but you get the idea. Even for achieve level questions, you've got to have 3 significant figures for excellence. So what do I do? Do I make it its 13.2 or do I make it 13.3? 13.3. Okay. Supermarkets round down. Okay, in shopping. Science rounds up. Okay, so it's 13.3 grams. So that would be your final answer. Okay, straightforward enough? Or are there any questions? I just see all good. Okay, right. So let's go to this one. So again, whenever you get given a question, you look. Now this is for the first time I've introduced two different things. So notice I'm talking about iron and I'm talking about iron oxide. They are two different substances. And when I use my equation of N is equal to small m over big M, I can only use one substance in it. Because if I'm trying to calculate N and I use my mass of iron and my molar mass of iron oxide, what amount am I calculating for? For iron? For iron oxide? I don't know, because I've used both of them. So you have to use, if you want to have the amount of iron, you've got to have the mass of iron and the molar mass of iron. If you want the amount of iron oxide, you've got to have the mass of iron oxide over the molar mass of iron oxide. Okay, so first of all, write what you've been given, and I'm just going to, actually I'll change these in a different color so you can, oh sorry, that's just being a real pain. I don't know if you see that thing coming up. Okay, sorry about that. Right, so if I do the Fe in blue, what am I given? I am given a molar mass of Fe, and I've got to calculate the mass of Fe, okay? But I'm not given anything else for Fe. And if I change my color and I look at what Fe2O3 is, can you see there is my mass of Fe2O3, and I can work out my molar mass using all that sort of stuff. So I've got a molar mass of both. All good so far? You've identified what applies to what substance. So now it should come up. Okay, no, I haven't got it. Okay, right. So it's always good to put down. I just want to check there. Okay, yep. I thought I had it there. So I've separated it out, and it's good to draw a column and do everything to do with the one substance on one side and everything to do with the other substance on the other side. The other way you can get around it is by always saying NFE or NFE2O3. So in other words, have the substance in brackets. That's the way I've done it in the booklets. But you can otherwise use this method. So I'm going to start with the green one, I think, because I have got the mass of Fe2O3. So I know that is 25 grams. And I'm putting in the three significant figures just to remind me that it is three significant figures. Your thing should always be three significant figures in the questions, actually. Right, what is my molar mass of my Fe2O3? Right, so I see Anon's typing. Okay, does anybody get 159.6? Okay. Now that is four significant figures. Don't try and round it off. That's just the way it happens because it's a big substance and it's a heavy substance. So this is grams per mole. Now, if I'm given those two, mass and molar mass, what can I calculate? Because what I've tried to show on the outside of here, if you've got the mass of substance A and the molar mass of substance A, you can always calculate the amount. Right, in moles, because it's in the amount, the counting, the ratio between the two is the way we swap from one substance to the other. So my N is going to be equal to 25, which is my mass, and it should ideally be 25.0, okay, divided by 159.6. Now, because we're in the middle of an equation, or middle of a calculation, I should say, write your answer to 3 significant figures, but keep all the figures in your calculator. So if I take my 25 and I divide it by 159.6, I get 0.1566416 blah 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 all the way through. Okay, so don't bother writing all those numbers. You can just write 0.156 or 0.1566 because you're keeping the rest of the substance in there, rest of the numbers in your calculator. So you don't really have to worry about rounding off because you could even go dot 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 if you like. And that answer is in mole because your grams have cancelled out your grams per mole over there. Okay, now to go from substance A to substance B, I have to use the coefficients. And if you give an equation, it'll be the numbers in front of the substances in the equation. If you get given a formula, you have to look at these little subscript numbers in there. So it's looking quite messy, so I'm going to write it up here again. If I've got Fe2O3, can you see for every one, I meant to make that a different color, there. For every one Fe2O3, how many Fe's have I got? So how many ion atoms have I got in one ratio unit of Fe2O3? 2. Okay, so that's where I look to see the ratio. So for every one Fe2O3, I've got twice the amount of Fe. So I can say my NFe is going to be twice what I had calculated on the other side. So it's going to be twice 0.1566 blah blah blah. So keep all those figures in your calculator and just simply multiply it by 2. And you should have 0.313. Okay. Sorry, I don't know if you lot find it very easy to write on the screen sort of thing. I don't. Okay, now if I've got the amount, I just need the molar mass of B to calculate the mass of B. So my M for Fe is going to be, and we had done it the previous time, so hopefully you'll know I'll take my molar mass and multiply it by moles. So we know what our moles is, 0.313, and I've kept all the figures in my calculator, even though I'm only writing to 3 significant figures here. And my molar mass we had calculated, we don't have to calculate it, it's highlighted there in blue. Question, is it 55.8 or is it 111.6? What is my molar mass? So my mass of 1 mole of iron, 55.8, correct. Okay, so remember when we're looking at molar mass, it's the mass of 1 mole. So we looking at 1 mole of Fe, so it's 55.8. If the substance was Fe2, which there isn't such a thing, then it would be twice that. But you don't get a substance called Fe2, so it can't be that. So you take that and you multiply it by 55.8. Is everybody clear about why I don't multiply the 55.8 by 2? because I know that's often a common error. Okay, it's in the concept of molar mass, the mass of 1 mole. So I take this and I multiply this by 55.8 and I get an answer of 17.48 blah blah blah. So just to make sure you know how to round, if it's 17.48, I don't have 3 significant figures, so how do I make it 3 significant figures? What should the answer be? 17.5, correct. And what else do I need to add to make sure that I have got excellence? Grams. Okay, so this is an example of an excellence level question. Okay, you've had to do one step to get the moles of one substance. You had to apply what we call the mole ratio, where we doubled the number of moles, and then you had to do the second step to get it to mass. So if you can do a question like that, you're at excellence level. Okay, so it wasn't that tough, was it? Okay, nobody's converting themselves, but anyway, no. Okay, so here's now one where there's an equation involved. Okay, so it's the same thing that we have to do of drawing a line and getting our 2 substances. Now here we're looking at our 2 substances. There's the one, the Fe2O3, and make the other one in blue, there's the Fe. So I've kept similar ideas just so that the molar masses are going to be easy to work out. So we know the molar mass of Fe is a mass of 1 mole, not of 2 mole, as shown there. It's a mass of 1 mole, so that's going to be 55.8 grams per mole. Okay, and do you remember what the molar mass was for Fe2O3? Okay, it was at 150, some of you are typing, 159.6, great. So if actually I'll just do it all in the same question here. So if it's the molar mass here is going to be 159.6. Write your list out. Especially with your units, because it's sort of slowing me down, but you would write your units. I hope you can read my writing. That does not look very good. Okay, so what else do we know about Fe2O3? So look at this over here. This calculate the mass of Fe is not Fe2O3, but we do have the mass, correct, of Fe2O3. Okay, and we've worked out the molar mass. Great. So I can write the mass is equal to 125. Okay, grams. I'm trying to push ahead because I really want to finish this. But so my N is the next step. If I've got molar mass and I've got mass, I can work out N. So you always work it down to the moles. If you don't know what to do, calculate moles. Okay, so it's going to be 125. Notice 125 is to 3 significant figures. So your answer will be in 3 significant figures. Divide that by 159.6 and you should have oh sorry, I've done the wrong thing. Did you get 0.783? As it'll be great if you can work with me on this, because it'll also let you know that you're using your calculator correctly. And of course the unit is mole. And always check, because if I'd given the mass in kilograms, I would have had to convert that first. Okay. Right, if I know the moles to get from A to B, I have to use my mole ratio. And if I'm given an equation, the way I do that is by looking at the numbers in front of my two substances. So 1 Fe2O3 is going to give me 2 ions. So is my amount of iron twice 0.783 or half? Because this is always a tricky bit when students don't know. It's twice. Okay, so if I'm always starting with the 1 and there's a 2 or 3 or whatever in front of the other one, it's always going to be double to find out the one I want to know. So it's going to be twice 0. Sorry, there's supposed to be a bracket, 0.783. And so it's 1.566 and so on. So what do I do now to find out my mass? Because remember, that's what the question wants. So see, Anon's typing and Emma as well. Okay, times by the molar mass. And so the molar mass, we look and we see it's 55.8, so our mass is going to be 1.56 times the molar mass, which is 55.8. Okay, so Emma, you got the M is equal to small m. M is equal to mass divided by molar mass, correct? But we're going to be finding mass, so we have to move the big M around. So it's 55.8, and again, it's useful putting in units so you know you are cancelling them out correctly. So I just go times 55.8. and I get an answer of 87.406. And I'll write that down because I want to check rounding. 87.406 and then dot dot dot. If I wanted to round that off to 3 significant figures, what is my answer going to be? $87.4, correct. So you must make sure you round off to 3 significant figures and you're rounding off correctly and put your unit in and you should be then fine. And that's again another excellence question where you've had to do one step to calculate moles. You can go either down or up, but then you had to convert to another substance and do another step of a calculation. Okay, so here's an example. Oh, I thought I actually had given an example where I used kilograms, but obviously not. So here's an example, and you do the same thing. You work out what you need to know. You've got CO2 and you are given Fe2O3. Okay, this CO over here is just like extra words, and it's not going to be part of your calculation. So there'll be some things given there that you don't have to know about. Just focus on the 2 substances you're working with. So substance A is always going to be the one that you know most about. And you know most about Fe2O3 because you get given the mass of Fe2O3. So we already know the molar mass because we've calculated before. That's why I've just stuck to the same substances. So it's 159.6. Okay, we know the mass, and I've used here because I find some students can't use the calculators correctly with exponentials. So make sure you know how to do this, how to use your exponential button. Okay, that's actually 3000, but I've done it in scientific notation so you can use it in your calculator. Okay, so if I've got mass and molar mass, what is the next step? I've got that, I've got that. So my next step is to work out N. And so using your equation of small m over big M, I'd like, if possible, all of you to try this one so you know how to use your exponential function or whatever way you do it, because every calculator is a little bit different. Did you get 18.79699 or something like that? So I'm going to round it off to 18.8. Yep. So it's 18.8 grams. Okay. Sorry. Is my unit grams? I did a mistake there. My unit is not grams if I'm calculating moles. What is my unit? It's, yep, I calculate moles. So just make sure that you write your correct units down, and that's why having your units during your calculation actually works, because you can check all the time. So we've got the amount, we've got to get now to this next substance, and so we look and we highlight what are our coefficients. I've got 1 in front of there, and I need to know CO2, so I've got a 3 in front of there. So how many moles of CO2 have I got? Do I multiply by 3 or do I divide by 3? I multiply by 3. Okay, so my number of moles of CO2 is going to be 3 times 18.8, and so that would be, I get 56.39. I hope you do as well. I mean, you could have made it 56.4 writing down, but keep all the figures in your calculator. So what's my next step? I've got to there. I've done that. What's my next step? The molar mass, and I multiply by the molar mass. So to calculate the mass of CO2, it's going to be, from my equation, as N times the big M. And as I say, use units to see if they cancel out correctly. Do you land up with grams? So it's going to be 56.39. Now, does anybody know what the molar mass is for CO2? If you want to calculate it quickly, it's 2 times 16 for the oxygens, plus, correct, so plus the 12 gets to 44. Well done. So you just have to multiply that by 44, and it's 44.0, so that shows you there is a 3 significant figure there, because remember, I'm harping on about significant figures. It's always the least accurate, because don't forget your decimal places gives you that third significant figure. So I multiply that simply by 44, and I should get 2481. Now 2481 is how many significant figures? 4. Now I could say 2480, but that's not the best way of representing it. So to use scientific notation, make it 2.48 times 10 to the 3. So see if you can use your calculator where it can toggle between the standard notation and the scientific notation. Because if you try and do that in your head, I mean, I've done that in my head now, but that's often where errors creep in because you miscounted.